Okay, so let's talk about pointers. So everyone should know what pointers are already, okay? Pointers hold for address of an object, allowing indirect access to objects they point to, okay? A pointer is a type, okay? So we talked about types before, bills, chars, ints, floats, doubles, etc. A pointer is a type itself, okay? Has a name, has a value, which is the thing it's pointing to, its memory address, and a pointer itself has a memory address itself. That's why we can have pointers to pointers, okay? Try not to have pointers to pointers, it gets very confusing very quickly, okay? But a pointer is itself an object and a type, okay? And so, as you'd know with pointers, you get the address of a pointer by using ampersand, and you get the value of what it's pointing to using the star, the dereference operator. Okay. Now, to minimize bugs, you should always make your pointers null when you start. Okay. C++11 does this by using null pointer. Okay, not by using equals 0. Okay, so if you're coming from the land of C, if you want a null pointer, you just set equals 0 or equals null, capital N-U-L-L, lowercase null pointer, C++11 style. Okay? The reason why you do the null pointer like that is if you use the capital N-U-L-L or the 0, if you attempt to dereference that while your code is running, it will probably crash, but I can't guarantee it will. If you try to dereference the null pointer, C++11 null pointer, it will crash and it will tell you that you've got a problem. Okay? And so what you can do is also with your pointers, and this again should be all revision, you should be aware that the star modifies a variable and not for type. Okay, so even though it's a pointer to an int, P at this point is a pointer to an int, but Q is an int. Okay, so be very careful again playing with these things. So int star there does not mean what you think it means. It means that P is a pointer and Q is an int. Okay? But a type mismatch like this will be detected by the compiler. So if you have a pointer to an int I, and then you try to say a pointer to a long is equal to the address of I, this will get picked up as an error because that's a long and that's an int. And even though it's a long int, okay, it's still a different type. So provided you got the compile and warning flags on, that will get picked up. Okay. So there's 2 bits of a pointer. It's a pointer itself and a pointee, the thing it's pointing to. Okay? And you can think of these things as being on your stack or on your heap like this. You have the address, you've got the variable names, you've got the values that they contain. Okay? So a pointer has a memory address, it has the value of the memory address it points to. Okay? So P points to I. I has a memory address, and it's got a value. I is equal to 5. Okay? Again, this should just be revision from first year. It should be really simple. But pointers can be complex. Again, annoying things to deal with, but you can have pointers to pointers. So a pointer to a pointer of double. You can have an array of oh, it's not 15, that's wrong. You can have an array of pointers to characters. You can have, so note very carefully the difference between these two things. This is a pointer to an array of pointers. This thing here is a pointer to an array. So, let's start again. Top one is an array of pointers. Next one down is a pointer to an array. Okay? Can you see the difference just in the syntax? You can then have function pointers. So a pointer to a function taken into returning an int star. Okay? And then you can have pointers within namespaces. So it's x : is a namespace, and it's a pointer to a member of x of the type int. Okay? We'll worry about that later on. And of course, as you can imagine, for misuse of pointers is a major source of bugs. Okay? So what we'll get to again in about week 4, week 5 is we'll kind of do away with pointers altogether, and we'll start talking about smart pointers. They handle a lot of the stuff automatically for us. Okay, const. As you can probably guess, const is constant. Okay, it means that once something gets defined const, you can't change it. Okay, so if we have int x equals 1, and then we can say x plus plus, okay, x becomes 2. If we say something's const, so const int y equals 1, and then we try to say y plus plus, so we'll compile error at us saying you can't do this because it's const. Okay? This is much safer than C's version of has defined y to be 1. Okay? Because for has defined, just substitutes every time it says y, it replaces it with 1. Okay? Now, admittedly, in this example, 1 plus plus doesn't make any sense. Okay? But use const. It's much more powerful, and you'll see that in the coming couple of slides. Okay? You can initialize variables that are const to be not const, and vice versa. So int a is not constant. A is just a value called a. It's 1. You can say, give me a constant of b, which is equal to a. And so that means that for 1 gets substituted into b, you can go change a all you like after that, and b remains at 1 it was always set to. And you can do it in reverse. So you can say constant a is equal to 1. Okay, so a can never be changed, but then int b is equal to a, and then you can go change b all you like. Okay, that's fine. So the primary role of const is to say something's immutable. It can't be changed. Okay? And so many objects don't have their values changed after they've been initialized. Okay? So many pointers are read through but never written to. What that means is you have a pointer to an int. You might constantly change the thing that pointer is pointing, so the value that pointer is referencing. So say you've got a pointer to an int whose value is 5. You might change that value from 5 to 10 or 15 or 20. You'll very rarely change that pointer to not point to the value of 5 anymore, but points to some other piece of memory that's got a different value. You'll very rarely change that thing. Okay? And the same applies with function parameters. Often you'll pass data through to a function, and you won't modify what you've been passed through. So going back to C style, but you've got strcomp over here, and strcopy. So let's start with strcopy. Strcopy takes in a char star of the destination and a char star of the source. You make the source const because you're not going to change it. You're not going to change for source. You're only going to change for where it's going to be copied to. Okay? Now, if you get rid of const there and compile that, most of the time that will compile completely fine. But if you stuff up for writing of strcopy and do the wrong thing, that will compile and won't warn you, and you'll get a runtime error. Putting const there allows you to debug your code. It allows you to say, hey, you're doing something wrong. If you just declare something to be const and you go and try to modify it, you're obviously doing something wrong. The same happened with strcomp. So strcopy, you need one thing to be const, one thing not to be. Strcomp, which just returns a number saying where do these two strings differ, both the left-hand side and the right-hand side can be const because you're not modifying the strings. Okay? Now again, bad slide here. This shouldn't be char star. This should be using strings, but we'll worry about that later. So let's talk about pointers and const. There's 4 different types, okay? And you're probably going to have to go away and read this later on. It will take you some time to get your head around, okay? I still get confused on these things sometimes. And you have 4 combinations of pointers and const. Case 1, you have a pointer to an int. Both the pointer and the int are not const. They can be changed. The second one you have is a pointer to an int that's constant. The third one you have is a constant pointer to an int. And the fourth one you have is a constant pointer to a constant int. Okay? So I've got 4 slides to illustrate this. Case 1, no const. We have int I equals 5. We have p, which is pointing to the address of int. Okay? So the pointer points to this 5 over here. We then say star p is equal to 6. So we modify the value that's being pointed to. That changes to 6. Then we declare int j to be 9. And we change the address of a pointer to now point to j. Okay? And that works. So 6 remains over here, j comes in here, and it points to it fine. Okay? Basics? Nobody confused at this point? If you are, let me know. No? Okay, so this is how you've probably been doing it your entire life until this point. Okay, this one. This is what's called a read-only dereference. Okay? We have int 5. We then have a pointer to a constant int. Okay? Now, our value here wasn't const, but we've just declared our pointer to be pointing to something that is constant. Okay? So we have I equals 5, that works there, that points to there. Now, we could have here said I++ and made I equals 6, okay? But we're dealing with a pointer only, okay? So the variable, I is still non-const, but the pointer itself is const, okay? So if we say star p, so we dereference the pointer and say it's equal to 6, it doesn't compile. Because what it's pointing to, it thinks is const, okay? But we can change where it's pointing to. Okay? So we can't change the value of which it's pointing to, but we can change where it's pointing to. Okay? So we can say it, instead of pointing to I, point to J. And it does that. But again, you can't say that star P is equal to 10 for J. It doesn't work. Okay? So for promise of a contract, if you're talking 2911 style, so contract programming, for promise of a contract is not to change the pointee. Okay? But the pointee can either point to a const or a non-const object, it'll be fine. Okay? People clear on this so far? Yep. Okay. Constant pointer. Okay? So now what we have is we have a pointer that itself is constant. So if a pointer points to an int, the int can be modified. So a thing it's pointing to can be modified, but it itself can't be modified. Okay? That means that we can now still say star p equals 6, which we could say before. Okay, and that works fine. But we can't now do p is equal to the address of j, because the pointer itself is the thing that's constant. Okay? And finally, if both of these things are constant, so it's a constant pointer to a constant int, we can't do for dereference change and we can't do for address change. Okay, as you can probably expect. Okay? 4 cases. It'll take you some time to wrap your head around them. Go take a look at them later on. Okay? Now, what you should be aware of where these stars go, okay? Char star const P1 is a constant pointer to a character. Char const star is a pointer to a constant char. Const char star is a pointer to a constant char. Okay, so see how the const has gone on the other side, but still the same thing? The trick to reading these things is don't read them left to right, read them right to left. Okay, so come back in here and read const. Okay, so it's whatever this thing is const. Oh, it's a pointer to a character. This thing is a pointer to a constant character. This thing is a pointer to a character that is constant, so it's the same thing. Okay, read it right to left, not left to right, and you'll understand it.